Okay then guys, let's have a little look at this paper. It's a C3 paper for the AQA examination board for June 2011. Let's have a quick look through the paper to try and simulate the thought processes one might go through if one was doing this actual exam. So you'd sit down in the examination at the beginning, and it's a good idea to flick through the paper. Basically, the reason it's a good idea is because it familiarizes you with the questions. So even though you're unaware of it, your brain is subconsciously working on the solutions to all those questions, and you familiarize yourself with them, so that when you come to actually do the question, some of the preparatory work will hopefully have been done subconsciously. So that can save valuable time. But also you can then, looking at the questions, you can see which ones are hard, which ones will take a long time, which ones are tedious, and arranging them in some sort of preferential order that suits your abilities and talents. So if you find some questions easy, then it's a good idea, and get them done in double quick time, it's a good idea to do them at the outset, just to get off to as good a possible start, which is so important when you're doing an examination. So with those thoughts in mind then, let's have a quick look at this paper then. Here's question 1. You got this log 6 of x coordinates easy, so there's no problem there. Find dy dx, well that's easy because it's just a function of a function rule. And then Simpson's rule here, which is slightly tedious and time consuming in some ways, but it's fairly straightforward as long as one doesn't make a numerical error. So this question is fractionally tedious, but is fairly okay for the most part, especially the first two sections. Question 2 then. Dy dx, product differentiation, constituent is a function of a function, then get the tangent at this point. Then a separate question here, quotient rule. Here, what's nice is you're given part of the answer, so that can save time when you're double checking, can't it? Because this is essentially already done, where k is an integer. So that's a nice problem, I quite like that. I think I would plan for doing 2 straight away. I'd leave the Simpson's rule question on the previous question, maybe till a little later in the exam, time permitting. 3, this curve inverse cos and this, or alpha show, this is a iteration problem here. Alpha lies between 4 and 5, so just take the difference and input these values. One will be positive, one will be negative. So change of sign indicates that it has a root at alpha between these two bounds. Then rearrange, which is easy, and then use this iteration formula with this first value. Again, it's not too bad. Fairly standard question there, no surprises. So that's question 3. So we'll look at 4 now. So 2 is the best one for me so far personally. Solve this trig equation. This is sine is minus a quarter when you invert the fraction, so we could write that down straight away. And solve, that's easy. Here we can use a quadratic, replace cot squared by its trig equation equivalent, trig identity equivalent in terms of cosec. Solve this quadratic, and that should be fairly easy. Hopefully, part of this answer will revolve around this solution here as well, which should save some time. Transformation question here. So as long as we get the terminology right, we should get that marks easy. Yeah, so that's that one. So again, that's not too bad. It looks harder than it is, but it's quite a nice question in many respects. So that's question 4. Inverse f and g, when they're defined on, why does f not have an inverse? Well, it's not 1-to-1, is it? Because it's a U-shaped curve. Inverse, find the inverse, take the range, which is the domain, of course, of g, and solve this equation. So that's not too bad at all, number 5, as long as you're familiar with inverses and ranges and definitions of functions. Here's a log question here, nice and easy, because you just unwrap the log, the 3 comes down, then log of x is 4/3, and then the log base number swings down, hits the 4/3 in the air, so x is e to the 3/4. So that's very easy to do. This is just a quadratic in log when you times by log all the way through. Rearrange and then solve the quadratic, probably by factorization, and then get the solutions. I like that question. I would certainly think about doing that one at the outset, or near the beginning of the exam. Modulus here, sketching them. Then when we've sketched them, we can solve. This has a solution at -1, x is -1, doesn't it? And so too does this. So they'll meet, they'll cross there. So we've got to be careful which angle they cross at, whether they cross over or underneath each other. And for that, you look at the derivative. This has a slope of 3 or -3, and this has a slope when you differentiate it of 2 or -2. So this will be steeper when it bounces off -1 than this line here. So that will have a bearing on the solution set, of course. Solve this equation when you solve it, and solve this inequality. Nice question. Could be tricky though, if you're not totally familiar with moduli and inequalities and sketching those respective curves. Substitution, this should be fairly easy. Nice little substitution, nice little integral. So that's a good question to do. And there's 9 questions in this paper, so I think there's one more. So let's have a look at that one. Integration by parts, lovely. Standard thing, totally user friendly. Then an implicit function, and just function rule rather. So dy dx is 2 of something to the 1 multiplied by the something differentiated, and you get dy dx. Then we're going to use root x log x and rotate it, aren't we? And get the volume generated. So that's quite a nice question as well. So some nice questions to do in this paper. 1 or 2 little awkward things, but nothing major. So when you've gone through the entire paper, then it's a good idea, if you've still got some time, to always double check all your work. Never go out early from an examination, because when you've double checked everything, then of course you want to triple check it all, so that you eke out every last possible mark you can from the paper itself, so that you do justice to all the hard work that you've done. So if you're doing a C3 paper in the near future, I'd like to just wish you all the best, hope you do well, and hope you get the marks you deserve for all your hard work. So I hope these live worksheets have been helpful, and this revision sheet here has been helpful, and hopefully I'll catch you again in another live worksheet. Cheers!